Hello, everybody, and welcome back. Today we are dealing with everybody's favorite F word, and that is fractions. Up at the top in blue, as always, YouTube channel and email address. Thought I would switch it up a little bit, make it give it the old school chalkboard look today. So we'll see how that goes. But yeah, just jumping into some fractions. I know they can be a challenge to some folks. They are a little bit abstract, but once you get the hang of it, they make a lot of sense. This may be a two-parter, I'm not sure, so we're going to just jump right in and see how this goes. So first off, just a reminder of what fractions actually represent is parts to wholes. So for example, 3/4, if you have a pie or a cake or whatever, these pieces right here are going to represent how many parts we're talking about and how many parts make up the entire whole, the entire item. So again, if I have a cake or a cookie or whatever you're thinking of this as, I'm saying that this 3/4 represents 3 pieces out of the 4 total pieces. So, just a quick reminder, basically. The number on the top of the fraction that represents the parts is called the numerator. Number on the bottom is the denominator. I would be writing in cursive, but I get people telling me they can't read cursive, so got to go ahead and keep it in print. So just a quick reminder, so when I'm talking about them, we know what we're talking about. One other note about fractions. Yes, they can represent parts of the whole. They can actually represent more than one, but the biggest thing that we're going to be dealing with here when it comes to common denominators and and reducing and all that kind of stuff, is that if there is a number divided by itself or a number over itself, the numerator and the denominator match, in other words, that comes out to be 1. This was always explained to me as, they called it the giant 1 when I was back in middle school, because it doesn't matter what you put over itself, it's equal to 1. 7/7, 3/3, 9,645,982 over itself does not matter. All equal to 1. That is because fractions are simply just division problems. So any number divided by itself gives you 1. Okay, so fractions are just division in disguise. So jumping right into this, reducing fractions. We always want to make sure that fractions are written in their simplest form, because it's going to give us the smallest numbers to deal with. It's going to be easiest. It's easier for us to deal with. So when we want to reduce a fraction, this is kind of going off of what I just said about any number divided by itself or over itself is equal to 1. You're going to divide both the numerator and the denominator by the greatest common factor of those two numbers. This can also be done if you don't know the greatest common factor or you don't want to take the time to figure it out. You can just divide by a common factor, by a number that they both divide by, and just make sure you do that over and over again until they can't divide anymore. But the quickest way to do it, if you know the greatest common factor, is to use the greatest common factor of the numerator and the denominator, because it'll get it done in one shot. So first example, 12/36. Okay, if you want to go back to our greatest common factor video, think back to that. I'm going to start listing out the factors of the smaller of the two numbers, because obviously the greatest common factor cannot be any more than 12, because these are the numbers that multiply together to give us 12. 1 and 12, 2 and 6, 3 and 4. So those are the pairs of numbers that multiply together to give us 12. So all I got to do is start checking this list, starting with the highest number to see if they divide evenly into 36, starting with 12. And oh, look at that. 12 does divide evenly into 36. So I'm going to divide the numerator and the denominator by 12, or in other words, I'm just going to divide this fraction by 1. Dividing by 1 does not change the value of anything. Think about that. You divide it by 1, you're still good. You multiply by 1, same value. It just may look a little bit different. So that's what reducing is. You're not changing the value, you're just changing how it's expressed. So 12 divided by 12 is 1. 36 divided by 12 is 3. And then we got to make sure we check always, all right, will 1 and 3 both divide by any other number other than 1? Because 1's a given. And that answer is no. So there's our final answer there. 12/36 reduced fully is 1/3. Okay. So you know, GCF is the way to do it in one shot. If you don't want to do the GCF, you just want to start going, that's fine too. Some people are a little bit more apt to do it that way. So we'll do an example like that. So 63 over 45. And first thing you might notice is that the numerator is greater than the denominator, and that is okay. That just means it's an improper fraction. That means that this is going to come out to be something that is greater than 1. Okay, so not every fraction is less than 1, but oftentimes that's what you're going to be dealing with. So 63 and 45, I might go, okay, well, let's find the GCF, the greatest common factor. Let's divide both of those numbers by that. Or I can just go, oh, I can look at that really quickly and say, I know they both divide by 3. Okay, great. So I'm going to divide by 3 over 3. I'm just going to tell you right now, this is not the greatest common factor. The greatest common factor would be 9. But we're just going to say I don't know that, or I don't want to think about it. 63 divided by 3 is 21. 45 divided by 3 is 15. So we have reduced it, but it's not in its simplest form yet. I hate this, jumps around. All right, so 21 over 21 over 15. You need to make sure that you just don't go, okay, I'm done, I reduced it. Yeah, you did, but it's not fully reduced. It's not reduced to its lowest form, or its simplest form. So you got to check again. 21 and 15. Oh, wait a minute. Those both divide by 3. So you can just do it again. Okay, again, that's just dividing by 1. 21 divided by 3 is 7. 15 divided by 3 is 5. Those are both prime numbers, so I know they won't divide by anything else other than 1 and themselves. So we're done. That's our final answer, 7 over 5. So it can be done without the GCF. It just has to be done multiple times. Okay, so just watch out for that. And then last but not least, 18 over 48. Okay, one more example here. So again, you could think of doing this with the greatest common factor, or you could just divide by a common factor multiple times until you get your final answer. So I always like to do this quick and easy, so I'm going to start with finding the common factors of 18 and 48. So 1 times 18, 2 times 9, 3 times 6. 4 doesn't divide into 18, 5 doesn't divide into 18, and I've already written 6. So those are my choices. So 18 does not divide evenly into 48, 9 does not, but I know 6 does. So if you just want to take a couple of seconds, that's all it takes. 18 divided by 6 is 3. 48 divided by 6 is 8. One shot, we're good. Okay, so just make sure we know how to reduce. You always want fractions in their simplest form. Again, the numbers are just smaller, easier to deal with. So, that being said, knowing that we can reduce, okay, adding and subtracting. We're going to deal with multiplying and dividing. It does look like this is going to be a two-part video, but adding and subtracting, I would say, is actually the more difficult of the operations, simply because you can't just go. You can't just start. You have to have a common denominator to be able to add or subtract fractions, meaning the denominator, the bottom, must be the same. And it makes sense if you think about it, because if I'm trying to add, 1/2 plus 1/3, well, a half and a third are not the same denomination. They're not the same size. So adding them, you're adding two inconsistent things. Okay, when you're adding just regular numbers, you're adding wholes, that's fine. But when you're adding parts, they need to be the same size part, so we know how many of that size that we have. Obviously, 1/3. Oh, OneNote's taken off on me. 1/3 and 1/2 are not the same. So let's go ahead and find these common denominators. One way to do this, and again, it doesn't have to be the lowest common denominator. Just like when you're reducing, you don't have to use the greatest common factor. It's just that it's going to be more work down the road. It's really not that big a deal. So one way to do this, again, is just by finding the lowest common denominator. That's the least common multiple of these two denominators. Okay, so 4 and 6. You might know this right off the top. If you don't remember, okay, well, start listing out a couple of these. Count by 4s, 4, 8, 12, 16, and count by 6s, 6, 12, 18, 24. Okay, I can see that the lowest common denominator is going to be 12. So I need to multiply these denominators by whatever they need to be 12. Keeping in mind that if I multiply the denominator by something, I have to multiply the numerator by that same thing. Okay, I can't just change the denominator because that will change the value of the number. I have to multiply by 1, essentially, on each of these. Move this over again to be able to keep this equivalent. So 4 times what gives me 12? Well, that's 3. So it means I must multiply the numerator by 3 as well. I apologize for these little doodads getting in the way. OneNote is acting crazy on me. So I'm essentially multiplying this by 1. And then what do I need to multiply 6 by to get 12? That's 2. So I multiplied the numerator and the denominator both by 2. Essentially, I'm just multiplying this number by 1. And I don't want you guys to get this confused with, when you're solving equations, because you're not, oh, I'm not multiplying both sides by the same number. Well, there's no sides here. There's no equal sign. I'm multiplying a singular value by 1. That's fine. You can always do that. It does not change the value. All right. So I've got both of my new fractions now over the same denominator, 12. Because 3 times 4 equals 12, 6 times 2 equals 12. Let's just multiply the numerators out. 3 times 3 is 9. 1 times 2 is 12. And so once we do that, we're able to either add or subtract the numerators while keeping the denominator the same. Now it's consistent. Okay? So now we have a common denominator. I can say 9 minus 2. That's 7. And then you always want to try to reduce. Take a look at these numbers real quick, 7 and 12. I know 7 is prime, so it only divides by 1 and 7. 12 will not divide by 7. We're good. Okay. One other little note here, guys. A lot of people, instead of doing this thing where you multiply, you got to find the lowest common multiple, you can just multiply the denominators by each other to guarantee you're going to find a common denominator. Because if I look at 4 and I keep going, 16, 20, 24, that would eventually have gotten us to over 24, which is fine. It's a shorter way to find a common denominator. It's not the lowest common denominator, but it is a common denominator. You just would have had to do reducing at the end. So without, in this case, you didn't have to reduce. Moving right along here, 1/2 plus 3/8. The denominators are not the same, so I cannot add these yet. Okay, I've got to find a common denominator. So yes, I could multiply, this one by 2 over 2. I can multiply this one by 8 over 8, which are just the same thing as multiplying them by 1s to get them over 16. Or if you have a little bit of math sense and take a second, I'm sorry for all the jumping around, you can realize that, hey, 2 is actually a factor of 8. So I don't even have to, what in the world? It's going back to the last mark I made. I don't even have to multiply this by anything. I can keep it as 3/8. And I can just multiply the left one by 4 over 4 and change 1/2 into 4/8. And this one's already over 8. So sometimes you don't have to do both. And that's okay. So just a quick reminder, if one's a factor of the other, you've got an easier path to the final answer here. So now that I've got a common denominator, I can add them, keep the denominator. Add my numerators. 4 plus 3 is 7. 7 over 8 is as simplest as it will go. Okay. And then one more thing to point out before we run out of time here. I'm going to try to go a little quicker. 3 minus 4/5. Well, this isn't even a fraction, so what do we do? Okay, well, a fraction being subtracted from a whole number is just the same thing as taking that whole number and making it into a fraction. So what fraction, 3 over what, gives me 3? Or 3 divided by what gives me 3? That's 1. Anything over 1 is itself. So just change whole numbers into fractions. I can get a common denominator of 5 by multiplying that one by 5 over 5. And you don't even have to change the 4/5. So 5 times 3 is 15. 5 times 1 is 5. So I've got it over 5 now. Minus 4/5 is going to stay the same. And I can just subtract. 15 minus 4 is 11. 11 over 5 is an improper fraction, but that's okay. It also will not reduce since 5 and 11 are both prime numbers. And so we have 11 over 5. All right, so join me for part 2. We'll cover multiplying and dividing. But I'm about out of time, but hopefully that helps, and hopefully I'll see you for the next part.